In this video, we're going to look at a mechanics question involving connected particles. In this case, we have a truck pulling a car on a tow rope. Whenever we have a connected particles question, what we want to do is we want to consider the two particles, or the two objects, the truck and the car, separately. So let's draw a force diagram of the forces acting on the car first of all. So obviously we have, in the vertical direction, we have the weight of the car acting downwards. The car has mass 1200 kilograms, so the weight is going to be mg, so 1200 g, and there's going to be a reaction force upwards. I'm going to call that RC, for R car, let's say. Now, what other forces acting on the car? It looks like it's being pulled to the right by the rope. So that's the tension the rope is pulling the car to the right. There's no other driving force within the car, but there is a resistance force of 800 newtons. Well, the resistance force is going to be acting against motion, opposing motion, so it's going to be 800 newtons acting to the left. So they're the forces acting on the car. Let's do the same thing for the truck. It's very similar. Again, we have an R upwards, we'll do the RT for the truck. And the weight acting downwards, in this case, because the mass of the truck is 2800 kilograms, it's going to be 2800 G acting downwards. Now we've got a driving force, a horizontal driving force of 3000 newtons. So we've got 3000 newtons sort of pushing the car to the right. And now the tension, T, is going to be acting to the left. So there's going to be a force to the left, T, and that's the same T as the T we had for the car because it's just one rope. Tension is the same throughout the rope. But in this case, it will pull the truck towards the left because tension acts towards the center of the rope. One thing we haven't considered is whether there's a resistive force on the truck. So the question doesn't mention it, but actually, if you look ahead to part B, you'll see the question asks for the horizontal resistance force on the truck. So we are also going to have a resistance force opposing the truck's motion. So going horizontally to the left, so we can just label that as F, currently an unknown force. Okay, so part A, find the tension in the tow rope. Well, we're just going to consider forces on the car in the horizontal direction. So let's consider to the right as positive. And let's resolve forces. Well, to the right we have T, to the right we have 800 is acting to the left, so that's a negative force. So T minus 800 that's the force acting on the car horizontally, so that's mass times acceleration. So T minus 800 is the mass of the car, that's 1200, times the acceleration, which if you look at the question is 0.4. So rearrange this, T equals 800 plus 1200 times 0.4, which is 1280 newtons, and that's the value of tension in the rope. Okay, so part B shows that the magnitude of the horizontal force acting on the truck is 600. Well, we're going to do the same thing, but rather than the car, we'll consider the truck now. Again, to the right, we're going to consider as positive. So what are the forces to the right on the truck? It's just a 3000 Newton force acting to the right. And forces to the left, we have the tension, and we have F, the resistance force. And this is again equal to MA. Well, for the truck, because the M was 2800, so we have this sort of equation. Now we can fill in some of these numbers because we know T is 1280 and A is 0.4. Okay, so we've made some progress. Let's just simplify. 3000 minus 1280 is 1720 minus F is, and then 2800 times 0.4 is 1120. So rearrange this equation, F equals 1720 minus 1120, which is 600 newtons, which was indeed the required answer in the question. So we're quite happy with how that went.